Hello, my name is Andrew, and I am the owner of WMH Racing. And today we are going to go over some of the case iterations for the Loadmaster. For right now, I just got all the analyzers and some motors on the screen. We're going to move this out of the way, and I'm going to show you a couple of the case iterations. So the first case actually had solid sides to it. I didn't have the vented ones, but I also don't have any more of the original cases to show you. But the design or the measurements of the case are the same. And those measurements are roughly 131 millimeters from lengthwise. There was a little bit of concern on my part when I made the first case. After a little bit, I noticed that if you put two two Trinity slot machine motors in it, that the rotors would touch. And if you give me a second, I'll grab another one of the Trinity motors and put it in there. And you can see that they just barely touch. Okay, so because of this, I decided to redesign the case and make it 5 millimeters longer. This redesign caused hobby wing motors. If you use a hobby wing motor as a test and a hobby wing motor as a slave, and I don't have two of them to show you, but what I can show you is that if you did that, you ended up with a gap like that. And with a gap like that, the motor coupler would not fit on the shaft securely enough. So I had to do another redesign. The newest redesign is back to the same dimensions as the original case. However, it looks a little bit nicer. I have inlays for the logo and inlays for the ABC phase letterings now instead of cutouts. There's the DRC logo for a cutout. There's my WMH Racing just lettering, and that was actually raised. I've kind of gone through this a little bit and trying to decide exactly what I like on these. But the dimensions are the same as the first case. And so what about the motors touching? Well, I finally decided that the rotors touching did not make a hill of beans of difference. The Trinity rotors seem to be the longest rotors. So I guess this is something I will revisit if somebody makes a rotor that's even longer. But at the current point in time, the Trinity rotors seem to be the longest. And the fact that they're touching, it really doesn't matter because we're tying them together with the coupler anyways. It's a solid shaft. So it's not going to cause any undue strain on the system. And that goes through my case design a little bit. There was another redesign in the case, and that is for the top cover that covers the spring clip retainers and the wires. Now, the original design, I don't know if you can see this, the original design was not quite as tall. And the original design was done on purpose with the 16 gauge wires on top of the spring clip retainers. It pushes up against the top and it creates a nice solid. Well, this one it doesn't create as solid because I raised it, but the original one created a nice solid, good pressure, and it held the motor in place pretty good. The problem with that, with the original design being shorter, is the Reedy SP5 motor, the tabs sit a little taller, and it was pushing up against the top so much that it would bow out. And of course, people are afraid they were breaking something or they're not pushing the motor in tight enough. So I raised it by 1 millimeter. And that's it for the case redesigns for the Loadmaster. But also today, I want to go over, we'll call them tips and tricks of using the Loadmaster. First thing, all Loadmasters come with a 1 ohm resistor bank. This is the standard resistor bank that I recommend to use if you are measuring the same test motor or same test motor and slave motor. Now I always measure the test motor on the left side and the slave motor on the right side, but it doesn't matter. It's just nice that the left side has the color-coded wires and the ABC. The right side just has black wires because it doesn't matter how you hook up the slave motor. And it obviously does matter how you hook up the test motor. All right. So there are a couple things we want to look at. One, when we do this, we still want to make sure, even though the rotor's held in here and it's held in pretty good, the rotor or the motor can turn. Obviously, this Reedy one can't. An R1 with its lower tabs can turn a little bit, and you can short the phase together. So I don't know if you can see it, but this middle one right here is shorting the C phase with the C. So the B and the C are shorting together on that tab. And you can get it to do it on the A tab too. So you still have to get the rotor in there decently straight. Now, whoa, camera. All right, I am not retaking this video for that, just to let you guys know. You're just gonna have to deal with that one. Okay. I don't know where I was. I was shorting this out. I did make the spring retainers as far apart as I thought was necessary to pretty much avoid shorting these out. If you are at least a little bit observant when you put the rotor in, you won't short them out. But you know, I know what happens. You just put them in there because you're in a hurry, and yeah, it happens. Now, the good thing is the Hobby Wing and the Motolyser will both give you an overcurrent error or a phase error, so it's not going to make any difference. Second thing I want to go over is with any of the analyzers, it is very important that you hook A to A, B to B, and C to C. It's not going to run properly, if at all, if you do not hook those up correctly, and you can cause overcurrents. You might be even able to damage the Tunalyzer or the Motolyser. All right, now on to the test motor, and I put my R1 in the slave motor. The slave motor also matters. You do not want to short out the phases on the slave motor either. Now, that's kind of a misnomer because with the resistor bank, we are shorting them out. We're just shorting them out through a little bit more resistance than if we had zero resistance. If you do short this out, you are going to create, as you will notice right there, so we get them shorted out, you're going to create more of a load. And if you create more of a load, it could possibly make the one of the analyzers go to an overcurrent because the load's too high. All right, so make sure that both the the slave motor, and good God, the test motor have both snapped in and they're not shorting the phases out. Next thing I'm going to go over is your choice of a slave motor. I've gone over this before in another video, but it's impressive that I do this again. If you are testing a 21.5 motor, this is a Reedy SP5 21.5, start out using a 21.5 as the slave motor. If you go to a higher wind motor, you will put more of a load on the test motor. Just to go back and reiterate, Hobbywing officially told me 12 amps is the current draw for the Tunalyzer. Now, I have personally had it up, and it does not do overcurrent until 20 amps. However, Hobbywing officially says 12 amps on the Tunalyzer. Motolyser told me 20 amps on the phase. Now, if you guys have gone through the Motolyser, you do notice that there is a difference between the total current draw and the phase current draw. And really this depends on where at in the load it is. If it is lower in the RPM range, generally the phase current is higher and the total current is lower. And if it's higher in the RPM range, you'll see the phase current will come down and the total current will go up. I think I have that right. Anyway, Motolyser says phase current, so you can't get the phase current over 20 amps. Regardless, both the Tunalyzer and the Motolyser will shut down. They'll go into an overcurrent mode if you exceed their current ratings. The Sky RC will also go into an overcurrent mode if you exceed its current rating. However, I have yet to find that. This is where I am going to explicitly state, do not use this with over 20 amps. The Loadmaster, don't run more than 20 amps through it. I did create vent holes in it to help with cooling if you are running at a higher load. But this is still PLA plastic, and these are battery spring retainers, and they're not designed to handle high current. All right, 20 amps is all I recommend. Don't go above 20 amps. You will start smoking things. Trust me, I've done it. All right, now we're going to run through, and I'm going to test each of the analyzers on the Loadmaster one more time to show you that it does work as advertised with all three units. And also, I'm going to use this time use this video to showcase my new bases for each of the analyzers. So the base will hold the Loadmaster, it will hold the analyzer, and in one 3D printed base. And we'll use this video also to show you the noise level, or so you can hear the noise level that is associated with each device. I do find that the Motolyser tends to be the loudest. It creates the most vibration, even with the same motor. I find that the Tunalyzer seems to be the quietest. I'm not sure. I'd have to put them back on my oscilloscope to see what the drive frequencies are. My guess is the Motolyser has a lower drive frequency than the Tunalyzer. All right, so I am going to start out with the Tunalyzer. And this is my new base plate for the Tunalyzer. It has a couple of nice cutouts. It's pretty small and compact, and this ends up being my favorite base plate. And the battery is done for when I do the Sky RC. Isn't that cool? The Tunalyzer, I mean, it sits on there pretty good, right? With the cutouts for the rubber pads on the back. And then we put in the Loadmaster. Now, I will reiterate on the size difference. Remember, this case is 5 millimeters longer. This case will not fit in the new base plate. However, if you bought one of the units and you bought one with the longer case and you want to buy a base plate, I will print you a new Loadmaster case for free. All right, I am going to use R1 21.5 for my slave motor. Remember, use the same slave motor as your test motor, which means we're not going to use a 17.5 as the test motor. We are going to use, I'm going to use this Reedy SP5. If I were to use the 17.5 with a 21.5, there will be a higher current draw. There will be more load. And that is because the 21.5 is a better inductor. All right, so like I said before, it does not matter on the slave side the order you plug in the resistor bank. And I'm looking for my sensor wire, which is right here. Now, I'm going to run the Tunalyzer and the Motolyser off a 12-volt power supply. The SkyRC you have to run off a battery, which is annoying. And C to C, B to B, and A to A. Let's hook it up to the power supply. Turn the power supply on. I like to use the auto motor test with the Tunalyzer, and I like to use the full motor test with the Motolyser. This gives the machine, it does its thing, it runs through its test, it gives you all the numbers, nice and convenient. You can write them down at your leisure without actually putting a load on the system. So we're going to do auto motor test. And there we go. We got a current of 7.59 amps, in-bell timing of 40.3 degrees, with the sensors pretty close since I hand soldered them myself. Let me tell you, that Reedy motor did not come with those sensors that close. They were about 5 degrees off. All right, so I want to show you what happens if we flip a phase wire. So let's flip a phase wire and let's go back. Now I'm gonna do a manual test on this one. You see how noisy and vibrating that gets, and then it does motor drive is abnormal. Please check the cable connection. That was from flipping a phase wire. So let's do that again. Manual motor test. Yeah, so it doesn't work very well if I flip the phase wire. All right, I'm gonna flip the phase wire back. And we're going to go where it needs to. Now I'm going to do something else, and I am going to short out. And there goes the camera again. I am going to short out the slave motor. So I'm going to turn this all the way, and I'm going to short that out. And then I'm going to do the manual test again. I don't want to run the full auto test on a system that I know is bad. All right, so manual motor test. All right. And that did not short out. Let's get it shorted out. There we go. You see how much current it's actually pulling right there? It's also the vibrations more. Okay. So, shorted that out just to show you that it's going to pull more overload. The vibration is going to be worse. It's actually going to be kind of a more lower pitch vibration instead of, you know, the normal vibration. And that's only because the RPMs are never going to get high enough to more, you know, kind of stabilize. All right. That is the Hobbywing Tunalyzer, which incidentally is actually my favorite of the 3 testing units for normal testing. I do say that because the Motolyser still, you can attach it to a Bluetooth printer, which is kind of cool. And it's still, you know, considered the industry standard. One of the main things I like about the Motolyser over the Tunalyzer, though, ends up being the RPM. You have to do a manual motor test with the Tunalyzer to actually get your RPM numbers. I find that annoying. Okay. We're going to pop this off, and we're going to move to the Motolyser. And the Motolyser base is it works, it does the job, but the Motolyzer has a round bottom, and it does make it so it kind of tilts a little bit in the base. I thought about bringing the edges up a little bit more to try to stabilize it, but then you have a USB port and the sensor port, and I didn't really want to make cutouts for those. And then, yeah, it's bigger and it's a little bit more awkward to store, more awkward than it already is. So I just kind of left it at there. Now it is pretty, I mean, it's in there. I mean, it's not going anywhere. So the base works fine, and it is, you know, I do have the unit angled slightly for easier viewing. Obviously on this camera, not very easy viewing, but it's because I'm looking down. All right. So now we're going to hook up the Motolyser and do a test. And I do think the Motolyser ends up, as I said earlier, I think the Motolyser ends up being the loudest of the 3 analyzers. All right. So again, C to C, B to B, and A to A. You should get the positive and negative right too, but there is reverse polarity protection on these, so it's not as huge. And then we have our resistor bank as well. All right, I'll flip it on. The power's on, yay. All right, full motor test again. Yeah, I think what it is the Motolyser actually just measures at a lower RPM on the first round through than the SkyRC, or not SkyRC, but than the Tunalyzer. So the high end sounds about the same. So here we notice the Tunalyzer read about 8 amps, and the Motolyser reads 5 amps. Let's see what the actual phase current says, and my guess is going to be close to 8 amps. And we got 8.04, 7.87, 7.89. Like I said. And another thing was, I believe the Tunalyzer read like 40 point something degrees, and this is 38.9, deviation of 0.2. Again, I used the Motolyzer when I actually set these sensors. So I mean, you see I got 38.9, 38.7, 39.1. I mean that's pretty damn close. The Tunalyzer shows those sensors just a little bit more off than the Motolyzer. All right, that's pretty much it for the Motolyzer. And the next and last one will be the SkyRC. And here's the deal with SkyRC. And I realize this is not a review of all the analyzers, but it kind of ends up being that way because I really don't like the SkyRC unit. The SkyRC unit is the cheapest, and I completely understand that is the one that most of the people have. However, if I wasn't making this unit, I would not have the SkyRC unit, and that's it. I actually sold my SkyRC unit. I bought a couple of them, and I've sold them. Every single time I buy them, I sell them because I just don't like it. You have to use a 2S LiPo with it, or 8-volt regulated power supply or something like that. Which, I mean, I can do that, right? I've made my own regulated power supply. I can run this off a regulated power supply. That's no problem. But it's not convenient for everybody else. So you have to use a 2S LiPo. Then, whereas the Tunalyzer and the Motolyzer, the full tests are regulated at 7.4 volts. The SkyRC isn't regulated. So it's hard to compare them. And then on top of that, the voltage numbers vary wildly, which means your kV numbers are going to vary wildly. However, I have found that the current draw seems to be all right. They managed to get the current draw right, which is a little bit surprising because the voltage numbers are off. But regardless, we're going to go A to A, we are going to go B to B, and we are going to go C to C. And now I need to find leads on my messy workbench. Sorry, the workbench is so messy. I've got other designs going on that I'm working on. All right. Again, nice little stand here. This stand is kind of the most bulky, and that's because the SkyRC unit is kind of bulky. I do kind of put it on an angle for easier viewing. And now I'm just going to do this. Alright, so I'm going to drop this down to, let's get close to, I can't even do it. I need to, I don't know. I equals that, I equals that, I mean 7.0 to that to 8.4, so somewhere in between there. Resistor getting warm yet? Yeah, they're starting to get warm, right? Alright, so I mean the current draw is going to be somewhere close, right? But again, this ends up being the reason why I don't like the SkyRC, and also the timing numbers are god-awful. So if we actually go back, I found this one's really not too bad, but let's go ahead and let it do its motor timing thing. And whistle the Jeopardy song while it's doing its motor timing thing. And feel the resistors, they are starting to get warm. Alright. And what do we get for timing? Average 38 degrees. Well, that's pretty close, right? 38, 37, 38. Well, like I said, this one's really not too bad, but it's still I've some of the units I've had, one will say like 34, the other one will say 38, and the other one will say 38. When on the Motolyser, they all read 38. All right. Regardless, you guys probably know all about that. All right, I'm going to unplug this. And the resistors are getting warm. I would recommend that you also keep an eye on the resistor bank and don't let it get too hot to the touch. Same with your motors, right? I'd say that this is, I don't know, 110 degrees, 120 degrees, which is fine. But yeah, don't let it get hotter than you'll let your motors get hot. And the PLA, this is what these printed out of. The PLA will start melting in 130 degrees Fahrenheit, so you'll ruin the nice little case for the resistor bank if you let them get too warm. All right, I am going to open this video up for questions and comments against my better judgment. But also, I will put down below, you can purchase my products at WMHRacing.com. You can purchase also all my products at DRCProshop, and you can purchase my Rotor Master at Rotor Rons. Thank you.